carbon dioxide, or CO2, is a big deal. I shouldn't have to tell you how bad it is for the environment. But speaking from my limited experience from the chemistry course I'm currently in high school, combustion reactions, which provide the majority of the energy on the planet, produce CO2. According to the EPA, in 2017, the United States got 62.9% of our energy from burning fossil fuels, such as coal and natural gas. CO2 having bad consequences for the environment is common knowledge, but some of the things I talk about on this channel aren't, and I have to do some serious research. If you're interested in what I'm talking about, you can find all of my sources in the description down below. But what if I told you there was a way to make super strong and useful carbon structures and breathable oxygen out of carbon dioxide, the very same that pollutes our world? According to the National Science Teaching Association, elemental carbon has four main allotropes, or occurring forms: graphite, diamond, fullerenes, otherwise known as buckyballs, and carbon nanotubes. Diamond is the hardest natural material, with a tetrahedral network that renders it extremely rigid, but is also probably the most boring and well-known of the forms of carbon. It is created when carbon in the earth is put under massive pressure, which forms the extremely rigid network that defines this allotrope. Fullerenes are a very newly discovered form of carbon, actually only being discovered in 1985. They have been suggested for use in a variety of medical applications, such as antioxidants or antiviral agents. One buckyball is made up of 60 carbon atoms arranged in a roughly spherical shape, similar to that of a soccer ball. Next, we have graphite. Graphite has a very strong planar geometry, which means that it naturally forms into strong sheets 1 atom thick. Atoms are strongly bonded to the other atoms in their own plane, yet slide easily because the interplanar bonds are much weaker. A single sheet of graphite is called graphene. Imagine graphene as a sheet of paper. Roll that paper into a long, thin tube. This is essentially what a carbon nanotube is. Carbon nanotubes are rolled tubes made of sheets of graphene that have super cool properties. Carbon nanotubes are made by either electrifying or shooting lasers at graphite suspended in a non-reactive gas, such as helium. Extremely high temperatures vaporize the carbon atoms before condensing on a cooler surface in the form of carbon nanotubes. Carbon nanotubes, or CNTs for short, possess extremely strong tensile strength, as well as being extremely lightweight. This allows for lighter, stronger, next-generation structural materials. CNTs have been suggested for use in bulletproof vests and proposed as a super light and strong tether for a space elevator. These are just a few of the possible applications for CNTs, which continue to be researched and developed. Elemental carbon is undoubtedly extremely useful, and there happens to be a way to get it while still cleaning up our planet. We have a lot of CO2 just sitting around in our atmosphere and being produced as we speak. Luckily for us, researchers at Caltech recently developed an experimental reactor that splits CO2 into C and O2 through a process similar to particle acceleration. Ionized CO2 molecules are propelled towards the inert surface of gold foil, where the kinetic energy sometimes breaks the bonds in CO2 into carbon, C, and diatomic elemental oxygen, O2. This is a new process because it replaces the energy needed for reaction, which is usually added as heat, with kinetic energy. Usually, because of the way CO2 is bonded, the molecule is broken into carbon monoxide, CO, and oxygen, O. While right now the reactor is very experimental, and the process only produces about 1 or 2 moles of carbon and oxygen for every 100 moles CO2 used, it is an exciting new technology. A possible application for this is space exploration, because creating breathable oxygen on a useful scale in space is an extremely difficult prospect. Despite the early phase of the CO2 reactor, it shows great potential for humanity's future in the stars, and also at home on Earth. Turns out, there's actually a much easier solution to all of our issues with CO2. Plants. Through the process of photosynthesis, they use H2O, water, and CO2, carbon dioxide, to turn into C6H12O6, glucose, a simple sugar, and they use that for food. Oxygen is released as a waste product from this, and that is where all of the oxygen in our atmosphere comes from. This simple reaction is extremely beneficial to humans because turns out we need oxygen to survive.
However, deforestation remains a serious issue.
Since humans have started cutting down trees, about 46% of all forests have been destroyed. Forests cover 30% of the Earth's land mass and used to cover much more. While forests alone do not produce all of the oxygen needed for the planet, they're still a valuable asset that should be valued, protected, and renewed. Until human science catches up to nature's efficiency, the best way to reduce carbon dioxide in our atmosphere seems to be simply protecting existing ecosystems, and to get your hands dirty, planting some plants. Caltech's reactor is an interesting step towards a sustainable future, producing life-giving oxygen and elemental carbon as a byproduct, which promises to make up the next generation of materials we need to build the future. Whether you believe in saving the planet or that humanity will take to their place among the stars, this process is a small step in what might become a great leap for all of mankind.